Hello, and welcome to Chapter 4 of our Artificial Intelligence course. I am Jose Antonio Menendez. In the previous chapters, we explored the meaning of artificial intelligence, its evolution, and the relationship between AI, machine learning, and deep learning. We also discussed some of the principal categories and applications of artificial intelligence currently in use. In this chapter, we are going to study one of the most revolutionary areas of modern technology: generative artificial intelligence. Generative AI allows computers to produce new content, including text, images, and audio. It also extends to music, video, and even computer programming code. Furthermore, it can generate presentations, business documents, and intricate product designs. Finally, it is used for simulations and the creation of synthetic data for training models. We will also examine large language models, commonly referred to as LLMs. You will learn what they are, how they work, and what tokens and prompts actually are. We'll also look at why generative AI makes mistakes and how to use it responsibly. By the end of this chapter, you should be able to explain generative AI clearly and use it effectively. Let us begin with a simple definition of what generative AI actually is. Generative AI is a category of AI designed to create new content based on patterns learned from data. Traditional AI systems, by contrast, often focus on tasks such as classification, prediction, or detection. For example, a traditional system might determine if an email is spam or predict customer churn. It might identify a defective product on a line or recognize a face in a photo. Other tasks include estimating future sales or detecting suspicious financial transactions. Generative AI can perform these tasks, but its true power lies in generating something entirely new. It may write an email, create an image, produce a summary, or generate software code. It can even be used to design a complete marketing campaign from scratch. A traditional model looks at a photo and says, "This is a dog." A generative model creates that dog. For example, create an image of a golden retriever wearing reading glasses in a university library. The first model classifies existing information, while the second produces something new. However, this generated content isn't created from nothing. It learns patterns from training examples. It learns statistical patterns, relationships, styles, and structures from massive collections of data. Generative models don't just copy from a database. They construct output based on probabilities. They build responses incrementally, guided by probabilities and the context supplied by the user. This table highlights the differences. Traditional AI classifies, while generative AI creates and drafts. In modern systems, these two types of AI are often combined for better results. Predictive AI might identify a business risk, while generative AI explains that risk to management. Generative AI has expanded extraordinarily quickly across the global population. The 2026 Stanford AI Index reports 53% adoption within just 3 years. This adoption is faster than the historical spread of both the personal computer and the internet. This is because generative AI changed how people interact with computers using natural language. Previously, users had to learn programming, database commands, and specialized software. Now, a person can describe a goal in ordinary words and ask the AI for help. You can ask it to summarize reports or translate messages into professional English. It can explain technical errors to beginners or analyze complex business spreadsheets. Technical knowledge remains vital, as experts can better evaluate and refine AI outputs. AI makes advanced capabilities accessible, but human expertise makes the results reliable. Generative AI is not limited to chatbots. Let us examine its major categories. Text models can create emails, detailed reports, articles, and concise summaries. They also generate contracts, procedures, and various types of training material. Image models produce illustrations, advertising concepts, and detailed product mock-ups. They are also used for website graphics, architectural designs, and educational visuals. Modern systems are multimodal, accepting both text and images to produce new visual content. Audio models handle narration, synthetic voices, and high-quality sound effects. They also provide transcriptions, translations, and even original music compositions. Video systems transform instructions or images into short, professional video sequences. Platforms like HeyGen allow presenters to produce content using avatars and synthetic speech. Coding assistants generate source code and explain existing programs to developers. They can also create SQL queries, write documentation, and generate test cases. Generative systems create synthetic data that resembles real-world data while protecting privacy. However, synthetic data must be validated to avoid reproducing biases or unrealistic patterns. A large language model, or LLM, is trained to identify and generate language patterns. Large refers to the enormous quantities of data and parameters used during training. Language covers words, grammar, style, and even programming languages and structured text. A model is a mathematical system that learns patterns and applies them to new inputs. At its core, an LLM predicts the next likely piece of text in a sequence. Modern LLMs use transformer architectures and self-attention to process broader context. The model uses context and prompts to choose from many reasonable continuations. LLMs are more than simple autocomplete. They process complex linguistic relationships. Large language models process text in smaller units called tokens, not necessarily whole words. A token might be a word, part of a word, punctuation, a number, or a symbol. Tokens affect processing capacity, usage costs, response length, and the context window. The context window includes the prompt, previous messages, and any uploaded documents. If material exceeds the context window, information may need to be summarized or removed. The transformer architecture was introduced in the 2017 paper, "Attention is all you need." Self-attention helps the model determine which parts of an input are most relevant to others. For complex instructions, self-attention weighs relationships between every part of the prompt. It is a mathematical mechanism for calculating relationships, not true human understanding. The creation of a modern language model involves several distinct and critical stages. Stage 1 is data preparation. Large collections are filtered to ensure high quality. In pre-training, the model learns to predict tokens and adjusts its internal parameters. Fine-tuning helps a model become more effective in specific domains like medicine or law. Alignment and preference training ensure responses are useful, safe, and relevant. Models are rigorously tested for accuracy, reliability, safety, and resistance to harm. After deployment, developers monitor performance and update safety controls as needed. A prompt is the instruction supplied to an AI model, influencing the quality of output. A practical framework includes role, goal, context, data, constraints, format, and quality check. Specify the role the AI should take and the goal it needs to accomplish. Provide context about your organization and the specific data the AI should analyze. Define constraints to follow and the specific format required for the output. Finally, add a quality check to ensure the results are verified by a human expert. Let's improve a prompt. "Help me improve" is too broad. We need industry-specific goals. The final prompt is specific, structured, and risk-aware, yielding more useful results. Modern AI is multimodal, meaning it can work with more than one type of information. This happens because models predict likely tokens rather than guaranteeing factual truth. A textile factory might combine images of defects with machine data for troubleshooting. A hallucination is when AI generates incorrect information but presents it convincingly. This happens because models predict likely tokens rather than guaranteeing factual truth. Reduce risk by providing reliable sources, requiring citations, and performing human reviews. Generative AI introduces risks including bias, privacy leaks, and cybersecurity threats. Organizations must define approved tools, permitted data, and clear review requirements. Practical use cases span business, IT, cybersecurity, healthcare, and logistics. Distinguish between an AI assistant and an agent that performs autonomous actions. Autonomous agents require strong controls like authentication, audit logs, and human approvals. Follow 5 rules. Give context, protect privacy, verify facts, keep accountability, and control autonomy. Reduce risk by providing reliable sources, requiring citations, and performing human reviews. Let's test your knowledge. What's the main difference between predictive and generative AI? Your assignment is to design and test one generative AI prompt using our structured framework. In summary, generative AI creates content, but responsible use requires human judgment and oversight. Thank you for completing Chapter 4. Next, we explore prompt engineering. I'll see you in Chapter 5.